right now, somewhere in the world, a multi-million-dollar shipment of critical medical supplies or, heavy machinery is sitting completely frozen on a concrete dock.
Just completely stuck.
Exactly.
Yeah.
And it is not stuck because a towering steel crane is broken. It's not delayed because a diesel truck blew a tire or anything like that.
Right.
It's sitting there literally rusting in the salt air because an email from a correspondent bank in London hasn't cleared yet.
Which is wild when you think about it, because
Hmm.
the physical machinery of global trade actually moves incredibly fast.
Oh, yeah.
We have engineered these massive ships and, automated ports that operate with stunning efficiency.
Uh,
But the invisible machinery,
the financial side.
yeah, exactly, the financial rails and the data systems that dictate who owns what and who gets paid,
Yeah.
that stuff is practically crawling.
Right.
I mean, the money is moving significantly slower than the metal.
Which really sets up this massive, almost violent collision between the purely digital world and the incredibly heavy, chaotic physical world. So, welcome everyone. Okay, let's unpack this. For this deep dive, we are looking at a source document today that is relatively short, highly technical, and honestly, completely visionary.
It really is.
Yeah, it's an excerpt titled Soroban Architecture for High-Volume Global Logistics Systems. And our mission today is to take this dense roadmap and explore what actually happens when next-generation digital code is forced to, get its hands dirty in the real world.
Well, what's fascinating here is the sheer ambition of this text.
Mm-hmm.
It stands out immediately.
It does.
The authors are detailing how stellar Soroban smart contracts, which are these pieces of self-executing code originally built to scale decentralized finance, or DeFi.
Right, the crypto world.
Exactly. They are being dragged out of that purely digital realm. They're taking this architecture and dropping it straight into emerging market logistics systems.
Which is a huge leap.
It's massive.
Yeah.
They're moving from the frictionless environment of digital finance into the highly unpredictable, weather-dependent, heavily bureaucratic realm of global supply chains.
Okay, so let's unpack the core crisis this technology is actually trying to solve first.
Good idea.
Because the source specifically describes congested legacy rails, the resulting fragmented supply chains, and what they call the chaotic reality of high-volume logistics.
Yeah, that phrase, chaotic reality, is spot on.
Right. I mean, if you've ever waited 3 business days for a standard bank transfer to clear.
We all have.
Yeah, imagine scaling that frustration up to a $50 million cargo ship trying to unload in a foreign port.
It's a nightmare.
But I want to push back a little here. Why is it like this? I mean, shipping has been around for centuries. We've had international trade since the Silk Road.
Sure.
So why are these legacy rails suddenly failing so catastrophically right now?
Well, the underlying issue is the sheer velocity of modern globalization.
Okay.
It has entirely outpaced human manual processing. I mean, to understand why those legacy rails are buckling, we really have to look at how international correspondent banking actually works.
Right, because it's not just a direct transfer.
Not at all. When a buyer in one country purchases a container of goods from a seller in another, their local banks often don't have a direct relationship.
Right.
They don't just magically beam money to each other across the ocean.
They have to use intermediaries, right?
Yeah, exactly. They use a whole
Right.
chain of intermediaries.
Yeah.
So a local bank sends a message, usually via the SWIFT network, to a regional bank.
Okay.
And then that regional bank sends it to a massive international clearinghouse,
Wow.
which then sends it to another regional bank, and finally down to the seller's local bank.
That is so many steps.
Again, every single step in that chain requires verification. It requires batch processing, which means transactions are pooled together and processed at specific times of the day.
Oh, right. So they aren't even doing it in real time.
Not even close. If a transaction hits a clearinghouse in New York at, say, 6 p.m. on a Friday.
It just sits there until Monday morning.
Exactly. It does absolutely nothing all weekend.
Meanwhile, the physical ship carrying the goods doesn't care about banking hours. It just keeps sailing over the weekend and arrives at the port.
Yeah, the ship arrives, but the trust hasn't arrived.
That's a great way to put it.
And that brings in another massive inefficiency, which is nostro and vostro accounts.
Okay, what are those?
Well, because these banks don't trust each other instantly, they literally have to hold accounts with one another.
Like essentially opening a checking account at another bank.
Basically, yeah.
Yeah.
And these accounts have to be pre-funded with millions of dollars in foreign currencies just to facilitate these slow cross-border hops.
Wait, let me make sure I'm getting this. So they have to leave massive piles of their own capital sitting completely dormant in foreign banks around the world,
Yes.
just to grease the wheels of these incredibly slow transactions.
That is the literal definition of trapped capital.
Wow, that's insane.
It is. And the text refers to this whole mess as the friction of physical trade. The physical goods arrive, but before a crane can even lift a container, a massive web of trust has to be manually established. Customs officials, port authorities, the counterparties, they all rely on paper bills of lading getting physically stamped.
Oh, man. Paper.
Yeah, physical paper.
So-
And they rely on letters of credit from these slow correspondent banks. Every single hop takes days. Every stamp introduces a delay.
So the container becomes financially trapped. The data pipeline is just way too heavy for the legacy infrastructure.
Exactly.
It's like trying to stream a massive 4K resolution movie over a 1990s dial-up internet connection.
That is a perfect analogy.
The system just wasn't built for the volume of data we're forcing through it today.
And in emerging markets, it's even worse.
How so?
Well, currency volatility might be higher, or trust between local institutions might be lower. So this friction is amplified exponentially.
That makes sense.
A buyer doesn't get their goods, a seller doesn't get their working capital, and millions of dollars just get tied up in this agonizing limbo state.
Right.
This is the root cause of the fragmented supply chains mentioned in the source material.
Okay, wait, I'm stuck on something here, though. Because shipping conglomerates have spent billions of dollars optimizing their ports. They have algorithms predicting weather patterns. They have automated cranes.
Oh, the physical tech is incredible.
Right. So are we really saying a blockchain network from the decentralized finance world is going to just waltz in and replace systems that massive global entities have spent decades building?
No, it isn't about replacing the cranes or the ships.
Okay.
It is about replacing the foundational software architecture that runs parallel to them.
Got it.
And the source actually pivots to this exact solution by introducing Soroban's Rust-based architecture and its reliance on high-throughput code.
Right.
They are proposing a system that bypasses those old correspondent banks entirely.
So what does this all mean? Let's demystify that phrase, Rust-based architecture.
Yeah, let's do that.
Because honestly, it sounds like a heavy metal band, but it's actually the structural foundation of how the solution survives in the real world.
It is. So Rust is a programming language, and it's specifically engineered to solve a very stubborn physics problem in computer science.
Okay.
Which is
memory management and concurrency.
Concurrency.
Yeah, in older programming languages, if two different parts of a program try to access or modify the exact same piece of data at the exact same time, you get a data collision.
Oh, like two people trying to edit the exact same cell in a shared online spreadsheet at the exact same millisecond?
Exactly like that.
And it just freaks out.
Right. And in older software architectures, when that happens, the system doesn't just politely decline. It often crashes entirely.
Oh, wow.
Or, even worse, it creates a tiny, really hard-to-find bug called a memory leak, which eventually degrades the system until it fails.
Yikes.
Now, if your web browser crashes because of a memory leak, you just refresh the page. No big deal.
Sure.
But if the software coordinating the logistics, the ownership transfers, and the financial settlement of millions of dollars of international freight crashes,
that is catastrophic.
Completely catastrophic. Which is why the source pairs Rust with the term high-throughput code. They aren't just processing 1 or 2 wire transfers an hour.
Not at all. A high-volume logistics system is essentially a data hurricane.
A data hurricane.
I like that. It's constantly pinging thousands of GPS locations. It is processing thousands of IoT sensor readings, checking the temperature inside refrigerated cargo containers so the food doesn't spoil.
Oh, right. All of that has to be tracked.
It's handling simultaneous ownership transfers. And Rust has this highly unique system of managing data ownership at the code level, meaning those data collisions we talked about. They are mathematically impossible.
Mathematically impossible. That's huge.
It really is. It is industrial-grade software. So when the authors talk about stress testing this architecture, they mean throwing the absolute maximum data volume of global trade at the network.
Just to prove that it will not buckle under the load.
Exactly.
Okay, so we have this bulletproof industrial-grade software engine humming in the background. It can handle infinite data without crashing. But software is fundamentally blind. I mean, how does a piece of code actually know that a physical 20-ton steel container has been lifted off a ship in Mombasa or Rotterdam?
That is the million-dollar question.
Because the source outlines a very specific mechanism for this. It says they are, and I'm quoting here, architecting automated escrow triggers that settle instantly, proving that sub-second finality can stabilize fragmented supply chains.
Yeah. The bridge between the blind software and the physical world relies on those automated triggers, which are often powered by optical scanners or IoT sensors.
Okay.
So when a container is physically lifted by a port crane, an optical reader scans its unique barcode or RFID tag.
Right.
That physical action generates a digital signal, which is fed directly into the Sordo smart contract.
Here's where it gets really interesting to me. This feels like the world's most high-stakes, high-speed vending machine.
A vending machine. Okay, I like where you're going with this.
Think about it. With a vending machine, the moment the internal sensor verifies your coin has dropped, the metal coil turns and the candy bar falls.
So
The physical action and the financial transaction are permanently mechanically linked. You don't put a quarter in and wait 3 days for a clearinghouse in New York to approve the candy bar.
no, you definitely don't. And that is the perfect way to visualize an automated escrow trigger.
Right.
The smart contract acts as the vending machine. The exact millisecond that optical reader on the crane scans the container, that digital scan acts as the coin dropping.
Oh, wow.
The smart contract recognizes that the conditions of the agreement have been met. The cargo has arrived at the designated GPS coordinates, and the trigger fires automatically.
And the funds are released instantly.
Instantly.
No waiting on a regional bank to open on Monday morning. No waiting for a piece of paper to be stamped in triplicate by some customs official.
If we connect this to the bigger picture, the profound impact of this mechanism is locked inside the phrase sub-second finality.
Sub-second finality.
Yes, finality is a critical concept in financial technology.
Okay, break that down for us.
It basically defines the exact moment a transaction becomes completely irreversible. The ledger is updated, it is mathematically verified by the network, and it cannot be undone.
Okay.
In traditional banking, finality is a shockingly slow process. I mean, a wire transfer might show up as pending in your account on a Tuesday, but it hasn't technically settled on the back end until Thursday.
Because the banks are still doing all that batch processing over SWIFT and reconciling those dormant nostro accounts we talked about earlier.
Exactly. But Stellar Soroban is architected to achieve mathematical finality in under a second.
Less than 1 second.
Less than 1 second. By settling instantly, you completely evaporate the financial limbo.
Wow.
Think about what this does to the concept of trust. In the legacy system, you have to trust the buyer in another country. You have to trust their local bank.
You have to trust the regional correspondent bank.
Right. With an automated escrow trigger, you only need to trust the mathematics of the Rust-based smart contract.
Because if the cargo arrives, you get paid instantly. And if the cargo never arrives, the escrow never releases the funds. It's binary.
It is entirely binary. The supply chain literally stabilizes because trust and payment are guaranteed mathematically in real time.
That's incredible.
The financial rails finally catch up to the physical movement of the metal.
This mechanism really is incredible, but I think it leads us to the grand finale of our source document, the ultimate objective stated by the authors.
The big so what?
Exactly. They claim that taking this high-throughput code and throwing it at the friction of physical trade is, quote, transforming theoretical scalability into operational dominance.
Operational dominance, that's a strong phrase.
It is, and I have to be a little skeptical here. Is operational dominance just an aggressive marketing buzzword designed to make investors happy?
Sounds like one.
Right, because decentralized finance is heavily criticized as being a closed loop. It's often viewed as a purely theoretical digital casino where people just trade tokens back and forth without ever affecting the real world.
Well, this raises an important question, and that skepticism is entirely warranted.
Okay.
Because for the longest time, the scalability of blockchain networks was purely theoretical.
Right.
Developers would publish white papers claiming their network could process 10,000 transactions a second in a controlled test environment.
Sure.
But a test environment is frictionless. It doesn't account for bad weather, corrupt officials, or a sensor breaking on a cargo ship in the middle of the ocean.
Exactly. It's easy to be fast when you're entirely weightless.
That's very true. But operational dominance is an entirely different, incredibly ruthless standard.
How so?
It means the technology is no longer a speculative playground. It means it is actively running the messy, chaotic reality of physical freight, Let's look at what operational dominance actually means in practice.
Okay, laid out.
Imagine a legacy bank trying to bid for the clearing rights on a massive logistics contract. They have to charge $3 or $4 per transaction to cover their overhead, their massive correspondent networks, and their weekend delays.
Right, and they still take 3 days to settle.
Exactly. Now imagine a Soroban smart contract executing that exact same transaction for a fraction of a single penny with sub-second finality, 24 hours a day, 365 days a year.
The legacy bank literally loses the contract.
They lose it every single time. Operational dominance means traditional shipping conglomerates and financial institutions will be forced to adopt this architecture.
Not because blockchain is trendy.
No, because they mathematically cannot compete with the cost and speed of automated finality.
Wow.
The authors aren't just using a buzzword, they are planting a flag. They were declaring that DeFi is graduating from the digital casino and becoming the dominant operating system for global physical trade.
That is a staggering transition to think about. I mean, we started this journey deep in the absolute muck of the real world.
We really did.
We looked at the chaotic reality of fragmented logistics, where incredibly fast physical ships are held hostage by slow-moving paper and clunky correspondent banks hoarding trapped capital. Then we moved through the proposed solution, which is bypassing those legacy rails entirely, using the high-throughput, industrial-strength, Rust-based architecture of Soroban smart contracts.
And then we examined how those automated escrow triggers act like a global high-speed vending machine,
Right.
relying on optical scanners to create a perfect bridge between physical movement and digital execution.
Resulting in instant sub-second finality.
Exactly.
And finally, we arrived at this realization that this technology doesn't just make things a little faster, it fundamentally stabilizes physical trade.
It changes the game completely.
It pulls decentralized finance out of the theoretical realm and drives it toward absolute operational dominance by just outcompeting the legacy rails on pure cost and speed.
You know, this matters profoundly, regardless of whether you work in logistics or software development.
Oh, totally.
You are looking at the blueprint for how the modern global economy is being actively rewired. Understanding how bleeding-edge digital contracts are solving ancient physical problems like distance and trust is a prime example of the future arriving in real time.
Right. The future is here.
The goods on your shelves, the supply chains your local economy relies on, they are all on the verge of moving from analog friction to digital finality.
It really is the ultimate collision of worlds. But before we wrap up today, I want to leave you with one final thought to mull over.
Always a good idea.
Our source material today focused entirely on this triumph of code over the friction of physical trade. It focused on achieving operational dominance by making trust automatic and essentially free.
Right.
But banks don't just move money, they sell trust.
That's a great point.
If these smart contracts actually achieve this, if they commoditize trust, automatically triggering instant sub-second payments and removing all of that historical financial friction, what happens to the massive industries, the international clearinghouses, the bureaucratic agencies, and the millions of human intermediaries who have spent the last century building their entire multi-billion-dollar business models directly on that very friction?
They're going to have a hard time.
When the friction disappears, what happens to the massive global industries that exist solely to sell us the grease?
It's a massive disruption.
Something to think about the next time you look out at a shipping port and listen to the chaos. Thanks for joining us for this deep dive.